All right, so I put these all sections put together because they're pretty much all the same when it comes to it. So nothing really brand new per se when it comes to these sections. So this is all basically right triangles along with sine and cosine itself, right? So why don't we just start off with a basic, right triangle. Okay. Now, believe it or not, there's an actual way to label right triangles, and we'll talk about both different ways to label a right triangle. Okay. When it comes to angles of the triangle, the angles of the triangle are always in capital letters. So, for example, this is angle A, angle C, and angle B, all in capital letters. Okay. How to label the sides is a little different as well. So the sides are always lowercase letters. Okay. And also the opposite angle you actually see it. So for example, this is angle capital A, so the side opposite of angle A looks down here, so this would be considered side small a. Okay, and you do the exact same process. So here's angle B, so the side opposite would be over here, so this is side little b, and then finally this is going to be little c. Okay, so that's how you label a right triangle when it comes to the letters and the sides and the angles represented when it comes to it. Okay, now also in general, we have a right triangle, right? So we have using let's say an angle theta here itself. We can also abbreviate that as well. Instead of using this portion, we have adjacent. So the adjacent side is the one touching the actual theta, and this represents the opposite side. Hence why it's the opposite of it, and this obviously is hypotenuse. Okay, so those are two different ways to do right triangles itself. So using the ABC method or the actual adjacent, hypotenuse, and opposite angles itself. Now the reason why I go over that is in this section, that's all we're really going to be doing for the first section is given a right triangle, how to find the angles or the sign of that angle associated with it. So for example, sine theta is opposite over hypotenuse, or in this portion, B over C, right, when it comes to it, and vice versa. So those are the main the 6 trig functions represented in a right triangle itself. Okay, so essentially let's just do a quick little example so you can see exactly what's going on. So it says find the exact values of the 6 trig function itself. So for this one, I have to give you the picture. So let's suppose this is our picture here. Okay. So there's a right triangle, and there's theta, and we want to find the other trig function itself, so the 6 trig functions. So in order to do that, we have to find all the sides of the triangle. So since we're given 2 sides, right, using Pythagorean theorem, we can find the hypotenuse. So I'm going to say h squared is equal to 3 squared plus 5 squared. So h squared is 9 plus 25. So this is h squared is equal to 36. So hypotenuse is going to be 6, right? Oh no, what am I talking about? 34. Yeah, ooh, way off. 34. So the hypotenuse is square root of 34. Okay. So in that case, now we can go back over here. This is the square root of 34. And now we just go straight down the portions. So for instance, let's talk about sine. So sine theta is opposite over adjacent. Opposite over hypotenuse. So the opposite would be, so you could say this is O for short, and this is A for short, and obviously this could be H, right? Using this template up here when it comes to it. That way it makes it easier to label stuff, right? So in our case, sine is opposite over adjacent, opposite over hypotenuse, so 5 over radical 34. Cosine is the opposite, is adjacent over hypotenuse, so 3 over radical 34. Tangent theta is opposite over adjacent, so 5 over 3. And then cotangent is the opposite, so it'll be 3 over 5. Secant theta is the opposite of cosine, so that's going to be radical 34 over 3. And then finally, cosecant theta is the opposite of sine, so radical 34 over 5 it there. Okay. And that's pretty much it. That's basically the first section of, the right triangle itself. So the other ones will go into laws of sines, laws of cosines, but that's pretty much for this one here.